Hello everyone. Today we will discuss about 2019 June single science physics paper. Let's look at the first question. Here you can see two of the equations are given related to power. And the first question is about radioactivity. Gallium-67 is a radioactive isotope of gallium used as a medical tracer. Medical tracers are placed in the body to diagnose illnesses. The tracers emit radiation which can be used to find the position of the tracer in the body. Gallium-67 can be represented using the symbol. You can see that the symbol is given, and hope you already know what are these numbers means. So here what we have, number 67 is what we are calling the mass number. And here what we have is the atomic number. Now if you can remember, mass number is the addition of number of protons and number of neutrons. So we'll put the hash sign to represent number of protons plus number of neutrons. And the question that they are asking is, give the number of protons and the number of neutrons in gallium-67. So we already know the atomic number is equals to number of protons. So here number of protons will be 31. Now to find out the number of neutrons, we have to use the mass number and the meaning of it. So I can rearrange this equation to say number of neutrons equals to mass number minus number of protons. So the number will be 67 minus 31. My answer will be 36. So number of neutron is 36. Next one, when gallium-67 decays, it emits gamma radiation. Explain why this makes it an effective medical tracer. Now in the question also they have explained what is a medical tracer. Medical tracer is if you have some especially to detect these cancers, we use medical tracers. Now imagine this is the body and there is some kind of a tumor cell or cancer in this region. So when we send this medical tracer, it will get go to this cancer cells and it will start emitting this radiation out. Now when it is emitting radiation, we can observe it from outside and detect it, and we can record in this region the cancer or the tumor is located. That is what is called, like the tracer is what is going inside the body and emitting this radiation. So we know if you compare with alpha and beta, alpha is not having that much of a penetration power that it can't come out from the body. Beta also, like beta is having much more penetration power than alpha, but still it will not be strong enough to go out of the body and reach this detector. So the only source that we can, or the only radiation that it will go towards the detector by passing through the body is gamma radiation, because it's having enough penetration power. So I'll write down the answer this way. We can say gamma has a high penetrating ability and gamma can be detected outside the body due to that reason. So if you have mentioned that gamma can pass through body or like the other alpha beta cannot be passed through, like that, I would not recommend to write that one, because here actually you have to talk about gamma radiation only. Next question, gamma-68 is another radioactive isotope of gallium that can be used as a medical tracer. Describe the difference between the nucleus of gallium-68 and the nucleus of gallium-67. So you can see that the mass number is different to each other. So how can they be this mass number different? It's simply because of the number of neutrons are different. Both of these are gallium, so that the atomic number or the number of protons are equal to each other in both of these isotopes. So we can say gallium-68 has a different mass number, or I will say different number of neutrons, and that difference is 1. Now if you have mentioned that gallium-68 is having less neutrons, that's going to be wrong. And like you can say gallium-68 has one more neutron, that is fine, than gallium-67. If you mention that too, that is correct. Okay, next question. Now this is a 6-mark question actually. Second question. Dentists take an X-ray image of a patient's teeth using photographic film. The film, which is initially white, changes to black when it absorbs X-rays. The film is placed inside the patient's mouth and the X-ray source is outside the patient's body. The teeth and soft tissues appears differently on the X-ray image. Use words from the box to complete the sentence. So the words that they have given is absorbed, emitted, reflected and transmitted. So let's see how it's going to fit into the sentence here. The tooth appears white because most of the X-rays are now you know teeth appears white, right? The reason is most of the X-rays are absorbed by the teeth. So here we will write absorbed by the tooth. The soft tissues appears darker in color because most of the X-rays are it's letting the X-ray pass through. So here if you look at the only answer that is suitable is transmitted by the soft tissues. Explain why the dentist has to leave the room before taking the X-ray image, but it is safe for the patient to stay in the room. That's a good question actually. Now patients are taking the X-ray and they are staying in that region and they are exposed to X-ray. But why these doctors or the dentist will move out? The main reason is these X-rays are they have ionizing power, and also they can damage cells, so that if the dentist is exposed for a longer time like this, the person is going to get very high dose into their body, which is going to be very harmful for the doctor or the dentist. Now here remember that even though that the patient is taking this X-ray once or twice, the doctors, if they are staying with the patient, they will have to stay for each and every patient. That's going to be so much time that they are exposed to radiation. So that's going to be a bigger problem. So we can you use this term like X-ray is harmful, but don't use that term because it's not explaining properly what is the hazard of this. Now, when you are learning the waves lesson also, you have been learning this the detrimental effects of these type of X-rays, gamma rays, all of these things you have learned. So we definitely know, or like we exactly know, X-rays cause cell mutation and they damage cells. So you can write those type of scenarios or sentences rather than just randomly saying it is harmful, because it's a general term and also it's not valid in this question answer. So let's write X-rays are ionizing, and we can say X-rays are ionizing and can cause cell damage. And we can say if the dentist stay with each patient, dentist would have greater dose. So since we have explained already what is the consequences of having X-ray or exposing to X-ray, X-rays are ionizing and they can cause cell damage, and also they can cause cancer as well. So if you want to finish this sentence, you can say that the dentist would have tendency of getting a cancer if he stays so long, like with every patient when they are taking X-ray. Next question. The X-ray used have a frequency of 3.5 into 10 to the power 6 Hz. State the formula linking wave speed, frequency and wavelength. This is a very famous equation, the wave equation. So we'll write down wave speed equals frequency into wavelength. Now I would recommend you to write the word equation, but if you have written V equals F lambda is also correct, but I would recommend you to use this word equation. That would be better. Next we will look at X-rays have a speed of 3 into 10 to the power 8 meters per second. Calculate the wavelength of these X-rays. So they have given the frequency first and they have given the speed. They want us to find out the wavelength. First of all, we'll write down our original equation, which is V equals F lambda. And we want to find out lambda. So if I rearrange this equation, it will be lambda equals V over F. And V value is 3.0 into 10 to the power 8 divided by 3.5 into 10 to the power 16 Hertz. Now when we do the calculation, we are getting the answer. It's a decimal value, like it's a little bit long, but we'll keep the answer lambda 8.6 into 10 to the power minus 9 meters. The value is it's a very small decimal value, 8.7571, and so I have rounded to 8.6 into 10 to the power minus 9. So I'll write the answer here, 8.6 into 10 to the power minus 9. The unit is given. X-rays are electromagnetic waves. Radio waves are also electromagnetic waves. State one other similarity and one other difference between X-rays and radio waves. Now, so we know electromagnetic, they have given X-rays and radio waves are electromagnetic waves. So we can't mention that one. But we know all the electromagnetic waves are transverse waves. So we will mention that both are transverse waves. Now, addition to this one, like they have only asked one, but I will discuss other things. Now, we know another thing, electromagnetic waves can travel through vacuum also, and also when it is traveling through vacuum, they have the same speed as the light. And we can simply say they don't need a medium to travel. We will write that one. Both waves can travel through vacuum. Both waves can travel through vacuum. And also the next one is both transfer energy and information, and they travel at the same speed, which is speed of light in the vacuum. But when it is moving in the other mediums, it changes a little bit. So you have to mention in the in a vacuum, when it is traveling, it travels in the speed of light. Next one, if you look at the differences between these two, radio waves, if you can remember the spectrum, electromagnetic spectrum, radio waves have a lower wavelength. Radio waves have longer wavelength, and also like they have smaller frequency with compared with X-rays, and X-rays are ionizing where radio waves are not. Okay, so we will move to the next question now. The graph shows how the distance traveled by an aeroplane changes during part of its journey. One thing very important in this graph is look at the starting points. The time axis is starting from 30 and ending at 60. The distance axis is starting from 300 and it's ending at 700. So we look at the question. State the formula linking the average speed, distance moved and time taken. So I'm telling like always Please write down the word equation which will keep your life in the safe side. So we will say average speed equals distance moved divided by time taken. Now, if you actually have written S equals d over t or V equals S over t, that is going to be fine. But the problem is sometimes now when you are using symbols, if you can't remember the exact symbol, you might give a different unit or different value there or different letter there. That's going to make our life very hard because then we don't know what is meant by that exact letter, but there are some specific letters given. For speed it is S, distance it is d, and time it is t. So if you are using that way, make sure you write the equation S equals d over t, nothing else. Like other letters that we have given different meanings. So please make sure you use better if you use the word equation. Calculate the average speed of the aeroplane during this part of this journey. Give a suitable units. So you can see this question is a 4-mark question, which is like huge. Yes. And to find out the average speed, if you can remember from this type of graph, what we have to do is we have to use the gradient technique. So here I would take this point as the final point, and also I will take this point as the initial point. So if I mark the values, now I'm just explaining it in detail. Like if it is the second point, I can say the x value is 60, and it's given in minutes. So I will talk about that later. And it's in kilometers. Here it is 700. So if I write the point for the first one, it's going to be 330, 300. These are the points. So I will use the gradient equation and substitute now. If I'm using gradient, I'll say S equals y2 minus y1 divided by x2 minus x1. Then I will take this value 700 minus 300 divided by 60 minus 30. But I know these values are given in minutes, so I'm going to put a bracket and multiply by 60 so that it converts into seconds, and also this one is given in kilometers, so I'm going to multiply by 1000 so that I'm getting the answer 222.22. This 2 is recurring. I'm going to keep it 222. Unit will be meters per second. Now you can actually do the calculation as it is, like kilometers per minute also. If you do the calculation by using kilometers and minutes, you'll get 13 kilometers per minute. And yeah, then 1 mark will be given for the substitution, 1 mark will be given for the evaluation, and also when you are substituting, like the distance and time correctly substituted in this formula would be recommended. And evaluation means getting the final answer, and the correct unit you'll get 4 marks. Then next question, during the flight the height of the aeroplane decreases. As the height of the aeroplane decreases, the temperature outside the aeroplane increases. Explain how the air pressure outside the aeroplane changes as the height of the aeroplane decreases. So first thing that you need to understand is when the height decreasing, the temperature outside the aeroplane increasing. So that according to the laws that we have learned about gas, temperature and pressure, first of all what happens is when the temperature is high, air molecules will have more kinetic energy, so that they will move faster and more often they collide with the aeroplane, so that pressure is increased. So we will write down those points. Let's say air molecules move faster due to the higher kinetic energy. So since they are moving faster, the molecules will collide more often with the aeroplane. So that pressure increases. Now you can say temperature is proportional to the kinetic energy. You can mention that way also, rather than mentioning due to the higher kinetic energy. You can directly say temperature is proportional to the kinetic energy. Okay. Next question. Question number 4. Photograph 1 shows Charles' toy. The toy has 2 magnets on a vertical shaft. You can see a vertical shaft and magnet A, magnet B and a support. Magnet A rests on support near the bottom of the vertical shaft. Yes. The student places magnet B at the top of the vertical shaft and releases it from rest. So it's released from rest. Magnet B is repelled by magnet A, causing it to come to rest again at the position shown. The table shows some energy stores in magnet B. So let's look at the question. Energy stores are gravitational, magnetic and kinetic. They want us to mention whether it increases, decreases or stays the same. Put a tick in the correct boxes to show whether the amount of energy in each store of magnet B increases, decreases or stays the same when compared to its value at the top of the vertical shaft. So let's go through this one more time to see what happens to the gravitational potential energy. They're asking stay the same when compared to its value at the top of the vertical shaft. Okay, so that means they want us to explain with compared to this point and this point. Magnet A rests on, a student places magnet B at the top of the vertical shaft and releases it from the rest. So definitely we can understand gravitational potential energy has been decreased. So we will mention that one, it decreases. Second one, magnetic energy. Now when it is kept at this point, the magnetic energy is less, but when it is closer to the magnet A, definitely it is increasing. Next one we will look at this point the speed is 0 because it's dropped or it's left in rest. It's just moving due to the gravitational force. So here V is equals to 0, and once it reaches this point also V is going to be 0. Because of that we can say the kinetic energy is not changing, it stays the same. Next question. This is a diagram of the toy shown in photograph 1. Magnetic repulsion force, and it's marked magnet B and magnet A is shown. One of the forces acting on magnet B is shown. Draw another labeled arrow on the diagram to show the other force acting on magnet B. So we already know that this magnet is balanced in this case. So due to that reason, we know that the same force will be applied. So we want the equal sized arrows to be there. This arrow size should be similar to the upward arrow. And this should be weight. Okay, moving to next question. The student adds a 10 gram mass on top of magnet B when it is stationary above magnet A and observes that the distance between the magnets decreases. He carries out an investigation to see the distance changes as more masses are added. Describe a method for the student's investigation If you answer, in your answer you should refer to the measuring equipment required, the independent and dependent variables, a way to check the reliability of the data. You may draw a diagram to help you answer. So let's think about how to set up the experiment. First of all, hope you can imagine what they are doing is they are adding mass onto the magnet B, so that it's going to the whole system, that part is going to become to have more mass. Because of that, it's going to go down little by little, even though that the magnetic force is trying to keep it upwards. Okay, when you are measuring the distance, in this case it's kind of harder to use a ruler, but using ruler is okay. Measuring tape is also okay, but I would recommend for you to use a vernier caliper, which would help to measure the distance accurately. So I would mention, first of all, use a caliper to measure distance. And also the mass should be measured, so that I will say use a balance to measure the mass. Then they are looking for the independent variable. Independent variable means what we are changing, so that in this experiment the independent variable is the amount of mass added. Then the dependent variable is the distance between magnet A and magnet B. Then we need to include how do we improve this experiment and ways to check the reliability of the data. So next point we will write down, repeat the readings and find the average value. And once you get a set of data, what you can do is you can plot the graph. And they can remove the anomalies, so that the experiment would be more accurate. Identify and remove anomalies. And also, when we are doing this measuring, you can use a set square to take the accurate reading. Use a set square to get accurate readings. Next question. The student removes the masses from magnet B. He then adds magnet C onto the vertical shaft, another magnet. And photograph B shows that when magnet C is added, magnet B moves further down the shaft until it is at rest again. Explain why the distance between magnet A and magnet B has been decreased. So we can understand when you keep magnet B and C like that, once again those two are also repelling each other just like magnet A and B. And when the magnet C is added, due to that reason, there will be some magnetic force applied downwards. That means the resultant force will be downwards, so that the magnet B will start moving a little bit downwards. Then it will come up to a equilibrium then again, so that it will stay stationary there. But here what they say is magnet A and magnet B, the distance in between those two has been decreased. The main reason is magnet C is applying a magnetic force on magnet A. So we will write magnet C provides downward force on magnet B. Magnet C provides a downward force on magnet B. So the total downward force on magnet B is greater than before. There will be a resultant downward force on magnet B. Due to that, it will move down. When B moves down, the force of magnet A on magnet B increases. Okay, let's look at the next question. The Sun is a main sequence star, and in the Sun's hydrogen nuclei are changed into helium nuclei, releasing energy. Name the process that changes hydrogen into helium. We know when these small particles join together, we call this process is nuclear fusion. Second question, describe the evolution of the sun when it leaves the main sequence. So first of all, you need to remember that sun is a kind of a smaller star. Because of that, it turns into red giant when it leaves the main sequence. So in the main sequence stage, the hydrogen four will get fused together and turn into helium. But there will be this one point then when all the hydrogen foil is over, it starts fusing other materials like helium, carbon, like that. So when this occurs, it turns into a red giant. So sun becomes a red giant, then it turns into a white dwarf. Then Sun's core has a mass of approximately 7 into 10 to the power 29 kilograms. Approximately 75% of the mass of the core is hydrogen. Calculate the approximate mass of hydrogen in the Sun's core. So you have to take this value and find out it's 70%, so that you can multiply 7 into 10 to the power 29 into 0.75. Then your answer will be 5.25 into 10 to the power 29 kilograms. Next one, when most of the hydrogen nuclei in the Sun's core have been changed into helium nuclei, the Sun will leave the main sequence. The Sun's core loses approximately 9 into 10 to the power 19 kilogram of hydrogen each year. Estimate the time until Sun leaves the main sequence. Give your answer to one significant figure. Now, time, we can find out the time. We'll say time equals we know the total amount of hydrogen available, that is 5.25 into 10 to the power 29 divided by within 1 year, this much of hydrogen is burned out, 10 to the power 19 kilograms. So that we can say time is equals to 6. It's also a decimal number, and it's like 5.56 into 10 to the power 9 years. You can round it and say if you want. Okay. Next question. Sixth question. A student investigates 4 cars PQRS. How is energy transferred usually from the engine of a car to its wheels? So this will be a mechanical transfer. So answer is D. The engine of the car burns petrol, which transfers energy usefully from the chemical store of the petrol to the kinetic energy of the car. The useful power output of the car's engine is 47 kilowatt. Calculate the useful energy output of the car PS engine during 15 minutes. So we need to find out energy. So we can use power equals work done over time or energy over time. I'll use P equals E over T. We know the power, so I will rearrange to find out E equals P into T. So when I substitute, power is 47 kilowatt. So I'm definitely going to write down this as 47,000. Time is 15 minutes, so 15 into 60. So my answer for energy will be 42.3 million. Into 10 to the power 6 joules. State the formula linking efficiency, useful energy output and total energy output. Yeah, we will write efficiency equals useful energy output divided by the total energy output. Next is the calculation. During the 15 minutes period, 2 into 10 to the power 8 joule of energy is transferred from the chemical store of the petrol. Calculate the efficiency of the PS engine. So we will say efficiency. I'm not going to write this equation again since we have written it already. And so the useful energy output is 42.3 into 10 to the power 6. So I'm going to write that 42.3 into 10 to the power 6 divided by during 15 minutes period, 2 into 10 to the power 8 joule of energy is transferred. So for that specific time that they have given, so we can substitute directly 2 into 10 to the power 8 joules, which will give me an answer of 0.21. I'm going to keep it as a ratio here. Okay, next question. The student extends her investigation by collecting data for car PQRS. She records the useful power output of their engines, their masses and their maximum speed. If you look at the reading, you can see that the PQRS engine useful power output is increasing and mass in kilogram is not exactly increasing except this car Q. Maximum speed is also increasing. Using information from the table, discuss the relationship between useful power output, mass and maximum speed. So you can see like the maximum speed is definitely having some kind of a effect on it, but mass is having kind of a variation because in the middle the mass is high. That means for the vehicle, the car Q. We can say, but simply we can say when the car's power increases, speed also increases. Next you can say, you can take this data and explain. For an example, the power changes from power increases from 47 kilowatt to 198 kilowatts via maximum speed. Changes from 41 meters per second to 68 meters per second. In the next point you can say, generally when the mass increases, the speed increases. We can't say always because we have this car Q as a little bit of anomaly, but generally we can say when the mass increases, the speed increases. And also we can take a set of data, like for an example, if you take car PQ, also you can see when the mass increases, speed increases, or you can say P and R. I'll relate P and R. So I'll keep it a little bit out. So speed increases. Car P has a mass of say 721 kilograms and speed is 41 meters per second. And R has 915 kilograms and 42 meters per second, which is higher than car P. So if you compare this way, like you can relate once again with power and mass also. If you take data from the graph and data from the table and explain it into a correct direction, that will be correct. But you have to use the data and explain it. Seventh question, the circuit diagram shows a 9 volt battery connected in series with 250 ohm resistor and another resistor X. Draw the voltmeter on the circuit diagram to measure the voltage of resistor X. Now we need to measure it here, so that voltmeter should be connected like that. The circuit in the current is 0.012 amperes. Calculate the resistance of resistor X. We know the total voltage given to the circuit. So we know the current as well. Then we can find out the voltage taken or shared by the component which is 250 ohms, or you can find out the total resistance of the circuit and you can reduce this 250 also. So I'll use that technique. Find out the total resistance. I'll write the equation V equals IR because I'm going to use that Ohm's law equation. So total resistance equals V over I. So V is 9 and the current is 0.012. Answer is 750 ohms. So the total resistance is 750 ohms. So this will be equal to the addition of resistance of X plus 250. So 750 equals 250 plus X, which means X equals 500 ohms. So this answer is 500 ohms. That's all then. See you with the next paper, and also please subscribe to my channel and share this video with your friends. Thank you.